After we start, I'm going to ask my co-hosts to please admit anyone else that might come into the waiting room and also to keep their eye out on the chat, please. Okay, let's start. So welcome everyone who's joining us in this Live Innovation Lab session. Today's Thanksgiving for those that do celebrate. Thank you everyone who's joining us today. Before we start listening to the amazing Kitty Yeung, we are first going to go very quickly over who we are, what Live Innovation Lab is, and what we do. So let's get started. Going back, we'd like actually to ask you to tell us who you are, where you, in which area you work. We've prepared a little poll. I understand I can launch it and then you can tell us using one of these numbers whether you work in the corporate area, whether you are part of the corporate world, but you work in innovation, or if you're an entrepreneur, a student, a coach, or any other. This just helps you understand who our audience is, and we really appreciate you helping us with that. The poll should be available throughout the whole talk, so feel free to just type in the number that belongs to the area you feel better represents yourself. A couple of things before we start regarding the code of conduct of our usual activities. Be respectful to each other. People in general are muted so that we don't distract each other. But if you're interacting via the chat and when we open for questions, remember to be respectful. We've muted you, as I've said before, and always be positive. It's about sharing and interacting in the most positive way possible. And obviously, we're all very thankful for the time that Kitty has taken to be here with us. And we also appreciate your time. And we hope you have a great experience with us tonight. Embrace the moment and the technology. You know, we normally a long time ago, before the end of the world, we used to do our events live. That's why we're called Live Innovation Lab, but we're not doing that at the moment, and we're exploring this new world. I think we're all slowly getting used to it, and it also provides us with a lot of opportunities. So do enjoy them and use the chat and participate in the polling. And as I said before, remember this is being recorded. So you could also look at it back in the future. You don't have to distract yourself taking notes. This material will be available afterwards. So before we start listening to Kitty, what is LILAB? What do we do? So Live Innovation Lab is a non-for-profit organization. We're based in Munich, Germany. And basically, we're all about the democratization of access to innovation. We want everyone, no matter who they are or where they come from or where they work at, to feel that they can innovate. Innovation is not a thing you do, is a way you think. And we especially like to support and encourage innovation by women and for women, not only, but definitely something that we believe in. And what we do, all the events we do, the workshops, the panels, the activities are about igniting, democratizing, and educating and empowering people for education. We've been doing this for about 2 years now. As I said before, during the first year, we did our events live. They were very hands-on, they were very interactive. And then this year, we've been exploring more the digital side of things. It's been a little bit slower, but hopefully, whatever comes next will involve both possibilities, being online, but also interacting in real life. If you want to learn more about us, feel free to visit our website or follow us on Facebook, LinkedIn, Instagram, whatever we have. I'm sure we have a slide somewhere over around here that explains where you can contact us. We work with 7 areas of innovation. So the different events we host and we create have to do with entrepreneurship, innovation DNA, social innovation, business, science and technology, art, design and media, and women in innovation. The event that we're hosting tonight is about women in innovation, but also art, design and media, and also science and technology. And many other things, actually. It almost covers the 7 areas that we have, and that's why we're so happy to have Kitty here. And I'll talk more about her. And then, of course, she'll do the talk, so you'll get to hear from her firsthand. One thing before I start fully into the event for tonight, we'd like to invite you at least to keep your ears and eyes open for next year. In 2021, we're going to launch the Innovators Mindset Lab. And this is part of the Play Innovation model, which is something that we've been working a lot on. And it has to do with a tool and a framework to develop innovation in a creative, joyful, game-based way. And this is going to happen next year. So if you follow us, you will find out when and where it's happening, and hopefully you'll be able to join us. So as I said before, I told you there's a slide where you will be able to see where you can find us. This is it. So take a picture or a screenshot or take notes if you want, and then you can for sure find out what's happening with Live Innovation Lab. So as I said before, I'm going to stop sharing now. This meeting is all about Kitty and what she can tell us about the work that she's been doing. And you might be wondering, who is she? Well, Kitty is currently a program manager at Microsoft Quantum Systems, but I would say if that's extremely interesting, but it's not the most interesting thing that she actually does. She's also the creator of the comic series Quantum Computing and Some Physics, the Quantum Computing Comics Notebook. She's also the founder and designer of a fashion brand that brings together science and art. It's called Art by Physicists. And it's very cool. She's going to talk a little bit more about that. I personally think Kitty really embodies what it is to bring art and innovation and science together. And what she does is pretty amazing. We're going to hear from her own mouth what it is. But that's not the only thing she does. She's also a technologist and lead at the Fashion Hack at Microsoft. She's a lecturer at Hackaday U and Microsoft Reactor on quantum computing, so pretty cool. She is a graduate of the Harvard University 2015 Applied Physics. And of course, I'm sure you can find her on LinkedIn if you want to learn more about her. So now, with that being said, I'm going to mute myself and let Kitty take the lead. And let's start this journey. I hope you guys enjoy it.
Thank you so much, Paula, and Maria, and Jarazan, for inviting me to this talk. Are you able to see my screen right now?
I am.
Okay, this is working? Cool. Okay, then we get started. Thank you everyone for joining. And as Maria mentioned, we thank all of you for joining, and especially people who are celebrating the Thanksgiving holiday and making the time to join us. So as Maria mentioned that I have some different areas that I work on. So I'm very happy to be sharing with you some of the projects and a couple points that I'm trying to prove through my projects. Just a little bit more background about myself. I started my professional journey as a physicist in the Cavendish lab in University of Cambridge, where I did condensed matter physics and did a lot of hands-on experiments for cold temperature physics, and is to study the quantum effects of materials. So I was building a lot of things by hand, and that had become a theme of a lot of things that I do. Because I love application, I then went to Harvard to do my PhD. There I was building plasmonic circuits, which is a very new type of circuitry using waves in electron systems. And you can create all kinds of electronic components. The plasmonic circuits, comparing to its electromagnetic counterparts, can be 100,000 times smaller. So it's a way to miniaturize our current electronics that we use every day. But it was very cutting edge technology, very, very new. When I graduated, that work was related to photonics. That's why I went to Intel to do photonics. So photonics has already been made into industry application. In data center, we have all those servers that are connected through optical fibers, and between the servers and optical signal, there's the interconnect where you have photonic lasers and photodetectors and waveguides, all kinds of photonic circuit structures that allows you to send information and convert information between electronic and optical signal. But then I stumbled upon something on the side, very interestingly. Intel, as well as during that time, many companies started building maker hardware. So they're open source hardware. You can learn to program all kinds of electronics, and they are all compatible. So I got to start to play our own products like the Joule module, the Edison Curie module that Intel was building. And I just started putting electronics into clothing and started doing wearables. And it was a lot of fun. But then I took a turn to join Microsoft. This is our innovation program at Microsoft, the Garage. From the name, you can already tell a lot of the innovative places, especially in Silicon Valley, started from the Garage. So I joined the Silicon Valley Garage as the manager, and it is a program that Microsoft uses to help drive an innovative culture and support employees to do their projects, whether or not it is related to their day job. The Garage provides a platform for people to expand ideas, to build teams, to build prototypes. So going way beyond the prototyping stage. So this was because of my past experiences doing all kinds of different things, including the wearables and the physics hardcore part. While I was supporting our colleagues to pursue their projects, I also had my personal favorite industries and technologies. One of them is quantum computing. The other one is, of course, the wearables. So I kept on doing these two as my areas of focuses. And I started learning quantum computing, even though I was a physics PhD and I did condensed matter physics. It didn't mean that I knew very much about the industry emerging field of quantum computing. So I started learning that myself, taught myself how to code in the Q# language, and then started teaching our employees inside Microsoft through the Garage program. So then that got me into the quantum computing team at Microsoft now. So I am a senior program manager, and I drive the education of quantum computing because this is such a beginning, such an emerging industry. We need a lot of education to help people understand how this technology works, in a way democratizing quantum computing. Exactly like on the right, we have on the left for you, we have these hardware that are built on really dedicated electronics and equipment. And then we want to teach people how this fundamentally works. Why are we building a new generation of computation comparing to classical computers? And then on the right here, you will see the coding, which is all open source. So anyone can join the workforce by writing things in Q# and building their own programs. So this is a really exciting field. We see a future that this new type of computation can be applied and help all kinds of industries. So this is what I do for my day job. And here is why I do the things that I do. And also there are things that my day job can satisfy, but then I still have broader ambitions, and I'm pursuing some of the other global goals that I'm showing here through some other projects. So you can see here I highlighted there are 17 global goals, which you can find these are determined as a lot of the most urgent problems that we want to solve on the planet. And for me personally, one person can do only so much, but I'm trying to stretch quite a bit. So what I do include quality education and reduce inequality and partnerships for the goals. But there are some other things that I'm pursuing, like industry, innovation, and infrastructure, and consumption and production, responsible consumption and production. I am pursuing through some other projects I will share in a bit. And on the right here is a concept that inspired me quite a bit. Is called ikigai. Is a Japanese concept that means a reason for being. So I will ask everyone to identify yourself on this chart where you are right now. I would say that I had times when I was in this quadrant, I was in this area where I was doing what the world needs. I get paid for it and I was good at it. But if it wasn't what I really love to do, then there's a feeling of emptiness. So I then learned to try very best to align all these 4 areas. It's very practical. It's not just, you can't just be doing something you really love but not get paid. So trying to align this 4 area has become a very helpful career confirmation. And it helped me to see that I'm being who I am, and I am able to make myself happy as well as contributing back to the society. So if you are on any of the other ones, maybe think about a way to shift it a little bit, try to align the 4. So this is one of the things that I do outside of my day job, which is my own fashion brand. And as you can see, it is really inspired by nature and science. And that's what I think what fashion intrinsically, beauty intrinsically are coming from. And there is another area called future, which I create to educate people, to create all kinds of latest technologies applied in fashion to show what is really possible with our current technologies. So I will show some of the examples in a bit about my brand. And you may see that there might be 2 parallel tracks that's going on. One is highly technical and of physics and engineering. The other one is more artsy. But it turns out that I see a lot of cross-section between these 2 paths, and they inspire each other, which are displayed in all of my endeavors now. That's what I really like to do, and where I feel ikigai is having the science, engineering, design, and art to overlap. To a lot of people, science and art may be very separate fields, and that's also part of our education where we are forced to choose one or the other and try to maybe from very young age to see these 2 fields separately. But they are really, really similar. To me, I think they are really exploring the cutting edge to study things people haven't done before and to explore the unknowns, to push the boundaries. Both of them would then inspire these practical fields like engineering and design. It is at the very interface between these 2 practical fields where we can build things that help people and people will need and love. So one of the examples, this is again a side project. As Maria mentioned, it's a class that I've been teaching. I see some of the audience here from the class today. Thanks for joining again. So since the pandemic lockdowns happened, I started teaching people quantum computing online. It was just like a very quick decision I made because I love drawing. Then there's nothing stopping me from making some comics that describe how physics works and how quantum computing works. So I prepared some comics every week. Every weekend, Sunday, I will post a new topic and then discuss this with the community for 30 minutes to an hour about that one topic. Since end of March to end of October, I've done more than 20 sessions to teach people about this. And we build a very good quantum community there. And it also helped me understand the people that are involved in this industry. Sometimes we may think that technology is only driven by the people who are going in the lab and then writing the actual code, the engineers and the technical builders that push the boundary. But it also involves a lot of people that would help the adoption and drive this industry to be broadly understood. So in this industry, we have people who really work on the mathematicians and computer scientists who come up with algorithms. There are also programmers who would use the algorithms to build applications. And there are researchers who need quantum to research some really hard problems that they cannot normally solve using classical computers. And of course, they're hardware makers. There are also a huge community of learners who are new coming in. They're passionate and very curious. They push themselves to learn deeper and deeper in this field. And eventually, they are able to join this workforce. And we're really hoping to see more and more people who can get through the barrier of thinking that quantum is something so difficult and they can never do it, but trying to work on things hands-on and build up open source code and reading about it can really help someone start entering the field. And then, of course, we need educators who can communicate ideas. One of the things that I learned through doing a lot of these innovative projects is that just having the technology isn't enough. And we really have to be able to tell stories and be able to educate more people. Otherwise, not enough people understand it, then not enough early adopters. People may already know this innovation technology adoption cycle. Most people are like there's a bell curve, and we need early adopters to push the early majority. And then there is a late majority, and then there are laggers who would not adopt technology until their current technology is completely replaced. So we need all kinds of people and people who can think outside of the box. And thinking outside the box also drove me to use this artistic idea to educate, teach people about all these concepts in quantum computing, and then the math, the language, how to write algorithms, and teach people about hardware and how to run their algorithms on hardware. So this all came together very nicely into a project. And then one of the things I also try to express is that we want to test our understanding in this hardcore science. And how do we do that? One of the things that I built over the years is that this way to test my understanding by converting from words to drawings to equations. You need to be able to elaborate what the equation is trying to show using words, but you also want to be able to condense words using drawings, condense very complex ideas into something visual and straightforward, and also equations to then express what the drawings are about. And we now have coding to help us do things that are practical. And the projects and the educational material were also featured in some of the publications. And at the same time, I'm building this quantum computing foundations learning path at Microsoft for people to get hands-on. These are the official materials, which also help me produce some of my own ideas and then converting that back into these official materials. It really was a very nice inspiration and bouncing back and forth. So for anyone who's interested in quantum computing, you can go to this aka.ms/learnqc, which is a very hands-on self-paced tutorial you can follow and very quickly start playing with quantum computing. So as a side product, because I drew so many pages, it then became a book. And I was very happy to be able to then publish this very recently. And turned out people really enjoyed it, but it's really just a byproduct. The content is already there. And the thing that I really enjoy is that people are learning something during this lockdown time at home. And then on the fashion side, as you can see, I have the nature and science as two categories. And how are they related to fashion? That's because personally, these are the areas that really inspire me. I think science, and the reason I chose physics is that it is a subject that describes how nature works. And nature is the intrinsic beauty in the world. And there are so many beautiful things that's beyond man-made, that is already existing and beautiful, and that inspires so many people in creating better ideas. So these are the very key themes that's not just for my fashion, but it's really to guide my personal development. I can show some of the examples of what type of fashion that I make, which is not very conventional. So for example, I build things like brain signal controlled dress, which is a dress that can reflect your brain signal. On my head, I was wearing this EEG headband that detects the intensity of thought, and you can program it to map to the colors and patterns on your dress. This is to show this application doesn't have to be in fashion, but it's a good demo to show people where technology is at now. This one is a machine learning dress. So in my hand, I was holding this Arduino 101 board, which had the Intel Curie chip. It has several key components like accelerometer, Bluetooth, pattern matching engine, and what's the fourth one? I can't quite remember the fourth one now, but I was using the pattern matching engine and accelerometer on here. So you can train the chip to memorize your gesture. And I mapped gestures to 4 constellations. Then next time you wave your hand in the correct way, the corresponding constellations will show up. This fabric is a page from my graphic novel that has a scientist and her robot looking into a telescope. So in the sky area, I would demonstrate these constellations, which are called by the wave of your hand. Also, an example of using body biometrics. This is detecting heart rate, and the blinking of the LEDs are reflecting your actual heartbeat. So not everyone wants to show other people their heartbeat, but this one I'm trying to show that if we can embed technology into everyday wear and clothing that anyone likes to wear, why not? So why do we have to limit our thinking in this maybe just bio devices? How about including it in everyday wear and make it wearable and helpful for people who can wear it every day or for special occasions. Why don't we make it beautiful? There's no reason why not. And the fabric is from my own painting again. It's the painting of a series of flowers. But those were a lot of hands-on building and very fun. And those are maker projects. I actually write the project into open source tutorials and teach other people how to make something similar. But then always there are people asking me where to buy my clothes. And that really got me interested in manufacturing because of curiosity, I didn't know how manufacturing works. And as a technologist, I wasn't really in the fashion industry. But then I started looking into how fashion clothing is currently being made, and turned out it's very hard for independent designers. Not just embedding technology into clothes, is also a lot of great ideas, like emerging designers want to make sustainable recycled materials, and they want to help people with disability to make custom design for them, and it's more personalized and maybe smaller volume. Turns out that's very difficult in terms of manufacturing. There are so many limitations. So I found out a lot of pain points in the industry. One is, as consumers, we all know when we go shopping, is all these mass-produced goods that's lying around. Oftentimes we see the markdown and sales. They are maybe a little boring, they're not personalized, not designed for you. And the size is not designed for you. You have to fit yourself into a size chart instead of the clothes fit to your body shape. For designers, the process is still largely manual, especially the traditional designers. They need to suffer from a lot of the back and forth and so many manual work, and all these processes can go on months and months and months. To develop a new design is very, very costly, and it could take a really long time. With our current technology, this shouldn't happen anymore. At least those prototyping stage can be cut down to 24 hours, but it's not done right now. And then most of the mass production is offshore, and people are working in not very good conditions. And mass production means efficiency. Factories like to produce large volumes, and turn out most of the clothes that are made are overproduced because brands never know how much they will sell. So we see these markdowns in shops, and brands are trying to get rid of their last seasons all the time. Turn out this overproduction of fashion contributes to a really major pollution problem. 10% of carbon footprint comes from the fashion industry. The way clothing are produced and manufactured is unreasonably problematic. So you can see that 30% of clothing ever produced are actually never made, ever sold. And they will be sent to landfills or incinerators and get burnt eventually. That's why should that happen? And that was heartbroken for me. As someone who loved art and the creativity, coming into the space thinking that this industry should be driven by beauty and creativity, it is driven by overproduction and pollution. So the fashion industry is well aware of the problems, and every single year there are a lot of talks about sustainability and self-destruction, maybe on demand, recyclable materials and all that. It's being talked about for quite a bit, but we are still shopping like this. And only when COVID hit, it was like a big wake-up call for the industry. But then industry predicts that when COVID passes, it may still bounce back to the really large volume production model again. That's not helping. What the industry really needs is something that can support creativity and also on-demand production. We shouldn't be making anything until someone already wants it. And also at the same time, help independent designers start with small orders, start with something new, and turn their ideas into reality much, much more quickly. So we need something that allows designers to turn their ideas into the actual products easily, which would then involve a lot of the latest technologies that we now have available. Like we can do automated pattern generation if we can build tools to do that, and we can allow consumers to directly tell fashion brands what they want instead of the other way around. We also need to democratize manufacturing, allowing designers to upload their ideas anywhere in the world, sharing ideas like GitHub on the cloud, and then sharing the standardized manufacturing processes with manufacturers anywhere in the world, the closest to their customers, and do on-demand production. And only when that infrastructure is really built, then these, what I showed earlier, those fancy things with hardware, electronics embedding into clothing, perhaps there will be more scalable solutions to build those creative ideas into scalable products. So this is something actually my hackathon project is doing. We have a really big team. This is just a small section of my teammates this year in 2020. And at Microsoft, I'm driving this movement company-wide. We have many employees from all over the world joining this project. And we're also working, collaborating with fashion industry leaders, fashion brands, manufacturers, and supply chain and software companies all around the world. So this is really something that only a huge collaboration like this can do. A complete ecosystem that drives on-demand mass customization for fashion. And only then we can really cut down all of the pollution, but at the same time, making creativity the driver of this industry. So it's a really huge project. It's going to take a while. So without those technology ready, what I'm doing with my own brand is something that also try to use what's currently available to achieve some of those ideas. For example, 3D printing is a very helpful model. It is like what I mentioned, if you can draw design in 3D, you can just upload it online somewhere, use a service or use your own printer and get it done, get it made one product at a time. There's no overproduction, do it on demand. And it's really rapid prototyping to production. And then similarly, we can build fashion brands like that, fashion designs like that, where 3D printing is easier because it's solid material. For fashion, it's soft material, it's harder to do. But we are going towards that technology where we can represent clothing digitally. You can simulate the movement, the draping. And if you can draw 2D patterns, you can create the 3D avatar of that. And you can even have people then telling you their measurements, and you can simulate patterns for anyone's body types. Is not a mature technology at the very moment, but it is going to happen. And I myself, for the brand, I'm getting ready for that trend, as well as collaborating with some industry leaders for the big industry projects. And then these are basically hardware improvements throughout the last couple of years. When I show you all these brain signal controlled, machine learning, those were all handmade. I had to manually solder all these electronics together into a circuit and the hard materials. But now we actually have some solutions that we can actually embed into clothing that are soft materials that are fabric electronics. So on the left here, I have one of the latest product that this year we launched. So my brand collaborated with Novacentrics on making these constellation LEDs that matches with the painting on the fabric as well. On the right here, this is an LED matrix. You can program it. You can draw anything into a GIF or image file or movie, you can use your phone, and through Wi-Fi, you can upload it to the dress. So if you paid attention earlier, this is actually the same design that I had for the brain signal Wi-Fi controlled design. But now it became a product. So this is what we can do with our current technologies. And there's no reason we can't make the latest technologies for fashion. And it's also a way to educate. So this is, again, another product that we recently launched is a Bluetooth connected brooches. So they are programmed to detect each other's distance. Think about a situation where a mother brings a child outdoor. So this actually happened to me when I was 3 years old. My mom almost lost me because she's shopping, she wasn't paying attention, and suddenly I wasn't there anymore. She spent like 3 hours looking for me, only to find out that at the very end, she was almost giving up. She saw 2 little feet underneath a big coat. When she opened it up, I was giggling inside and sweating the whole time. And I found it funny because I was only 3 years old, but my mom almost was, she was devastated. I almost thought that I was lost. So this was something that I created with DF Robots. It was also first a handmade prototype, but now we turn it into a PCB board that is itself a flower, a pair of flowers you can program to connect with your loved ones. There are LEDs, accelerometer, vibration motors, all on the same board. So for people who just like this functionality, it's a final product. But for people who love programming, this is a great tool for education as well. And so I talked about overproduction earlier, so I don't want to do the same thing for my own brands. Therefore, I'm always making these things at small volume. And also the profits made from the sales would be donated back to STEAM education and environmental protection nonprofits, because that's what I think before we can really create this made to order mass customization industry solution, there are already things that we can do as fashion brands, as individuals, and it should form a virtuous cycle. And this is what I think a virtuous cycle of the society looks like. This shows how our society advances. There's not really a starting point, but you can see that it is science and engineering technology that is driving all these useful technology and solutions being developed. Eventually we get to the machine and they can do automation. Why do we do automation? Because we want to produce consumer goods and infrastructure more efficiently. Once this human need is being satisfied, then that's when we can create art and culture. And why do we need art and culture? Because that is what's bringing us happiness, and happiness drives us forward in a positive direction. So this is basically my end note, is that technology is to empower people. Some people may think that more and more automation and algorithm would replace people, but in a way it is relieving people from tedious manual works that also coincide with people's increase of education level. But then eventually all of the things are done by machines. What's the point of humans? So in a positive sense, we think about nature, which existed way, way, way before humans or any life earthlings existed. But nature is the best artist and it's been creating all these beautiful things, which then fueled back to our imagination and creativity. And that didn't stop us from creating. And I think that's what happiness drives us going, and making is producing useful, meaningful things is activating our society to go in a positive direction. That's what I'm going to share today. Thank you very much for listening.
Thank you so much, Kitty. That was really inspiring. We learned a lot about what you do, but also how you really bring art and science together. This is definitely something that for a lot of us is new, and for sure, even if it's not new, it will be inspiring. We're now going to open for 10, maybe 15 minutes of questions. So our participants can write the questions on the chat. I will read them. Kitty will answer them. Of course, if there's some sort of conversation going on, that's also fine. We can handle that with me being the mediator. And I'm going to start by a very simple question that was asked a while ago. Well, simple, the question, I don't know the answer. Arun asks, what is the inspiration behind your logo?
The logo itself is a pair of Chinese characters. So art by physicists is easy to understand. And this is actually a similar translation of art and physics. This is a character in Chinese that is physics, and this is art, and they're overlapping. So it could be a literal translation of art by physicists, but it's also meaning things. This has another meaning of things and items, material goods. And this is the culture and art. They are overlapping, and it also represents physics. So it's in Chinese because I'm originally Chinese. So it also shows my origin.
Okay, thank you for that explanation. Anne asks us, don't you think COVID is also kind of a wake-up call, I guess, not only for the fashion industry, but also for the environment? And maybe then it would also have a positive effect on the impact of companies, among them the ones in the fashion industry. She feels environment is more of a central subject nowadays.
I totally agree. I also feel like it's kind of a nature's way to tell us, slow down, don't make so much things that people don't really need, and stop polluting the environment. I totally agree with that comment. And I think the model, the on-demand production model I presented right now is primarily for fashion, because that's where a traditional industry really needs to be upgraded to the latest technologies. But that can be expanded to a lot of other industries. Even all physical goods can be, for consumers, could be custom made.
That's a very interesting approach. Just to close on the logo comment before, Aaron says he or she, sorry, loves the thought process behind it. Another question from Martin, I'm going to assume. He says, it's a great presentation. And he asks, I feel interested in many subjects like philosophy, literature, and especially physics and medical engineering. Do you think there's a way I can study those subjects and put them together in some kind of work or research?
Definitely, I think just pursue what you love to do, no matter how many there are. I'm also someone who has just so many interests, but I think if it helps to find the most intellectually difficult one to focus on, and because that requires a lot of academic training. But then once you master that, the other things can be something that's you can do on the side. And if you can find like things like double major, you can try to do that. Otherwise, keep doing what you love to do. And eventually you will be able to find the sweet spot where you can combine all you love to do. It wasn't clear to me until after I joined industry. When I was a student, that's how I picked, was focus on physics, because comparatively, if I become a scientist, I may still be able to do some art on the side as a hobby. But if I become a professional artist, I may not be able to do science professionally. That was my thought process. But after joining industry, with the development of technology, it then became possible to combine art and technology. Maybe 10 years ago, it wasn't possible, but now it is.
Okay, let's move forward. Tamas asks, is there tension between electronics in the clothes versus nature?
I don't quite get the question.
So maybe we'll ask Tamas to please reformulate the question, and we can move on to the next one. So Danielle asks, what is missing today to scale this individualized production for fashion and art items?
What is missing are mostly these technologies are not being put together. The industry has been very segmented and everyone is using their own processes and there are many different tools that are not compatible. And there's not even, we've been making clothes for thousands of years and we have so much knowledge, but none of this knowledge is uploaded somewhere and shareable across the world. So a lot of the knowledge get lost. And there's just a lot of disconnect between different segments from like ideation to production to prototyping to production and to even retail and distribution. And because of the mass production model is also forcing a lot of quick and cheap and not a lot of products without a lot of thought. So it's not very helpful to promote art. Art is very unique. Art is what the artist would come up in a very creative way. And intrinsically is not something that should be mass produced. So is really a conflicting both culturally and technologically. It's not merging together yet. But we're trying to build this connectivity that would both allow customization and personalization and provide support to independent artists and creators, as well as protecting the environment by cutting down overproduction.
Okay, let's move forward. A question from our own team. How do you find time to work in all these projects? Do you have any tips?
Yeah, I mean, it's all time management. I think having a good schedule, I sleep for 8 hours, but then 24 hours minus 8 hours minus a couple hours eating. The other times I focus, I really focus on different projects. And I change my brain a bit, not just doing one thing, but doing multiple things actually helps with efficiency.
Okay, we'll take that into account for our own projects for sure. Tobias asks, how do you see the impact of zero marginal cost? I can hear my echo. And collaborative commons. I'm going to repeat, sorry, because I interrupted myself. How do you see the impact of zero marginal cost and collaborative commons, what Jeremy Rifkin describes in his book, on this industry?
I don't think I know enough about this yet to really make a comment, but I can read a little bit more about it too. Yeah.
Remember, it's always possible to engage afterwards when we post the video and when we post also our blog post about this activity tonight. And of course, you can look for each other on LinkedIn and engage and interact, which is part of what we want you guys to do. One more question from Anne. Do you know other applications of quantum computing in art?
At this moment, not quite, not really. And you don't really need quantum computing for art, I would say, at this moment. There's definitely art to help people understand quantum computing because art is a way to communicate. So it's really like an art application to support quantum computing other than the other way around. Reason being that quantum computing right now is specialized for certain areas. So for some applications that are very difficult to do on a classical computer, like simulating actual quantum mechanical interactions, like chemistry reactions, biological interactions, is intrinsically quantum mechanical and is very hard to compute in our, even the biggest, best supercomputer that is classical is hard. So it will make sense to use a intrinsically quantum mechanical machine to simulate such systems. But there are other areas like our everyday experience, like logistics, transportation, signal processing. These are these have classical solutions, but then they need better computation to make them more efficient. And we get inspired from how quantum mechanics works to write classical algorithms that run on classical hardware to solve problems better. But for art, I really don't see why at the moment, because humans can do better and nature can do better. But in a way, I think our universe itself can be imagined as a computer that is creating all these things that humans are not able to do. I don't know if you've read Hitchhiker's Guide to the Galaxy, one of my favorite books. It has a supercomputer, is probably, I don't know if it's quantum computer, but it's very powerful. And it calculated the answer to ultimate answer. And it says the ultimate answer is 42, but no one understands what that means. And the computer says, the answer you asked me for, the ultimate answer I calculated is 42, but you don't even know what your ultimate question is. I am not able to calculate the ultimate question, but I can tell you how to build a more powerful computer than me that can calculate the ultimate question. And that computer's name is called Earth. So expanding that, if Earth is in this book, it was created as a computer, then we can imagine the universe could be doing some sort of computation as well, but it's really beyond. It's like asking a question of what happened before Big Bang. Is beyond what we can really explain, but it is doing art. So it is using quantum mechanics as the operating system. So perhaps in this sense, this is application of our universe and quantum computing in art.
Well, science fiction is an expression of the combination of art and science at the end of the day, and you'll be fine if you have a towel. Before I ask a question myself, I would like to inform everyone that we might have time for one, maybe two more questions that are not anymore in the chat. If someone wants to add one, the time is now. My own question would be, you do this amazing mix, which is not common, that we know. How do people normally react to it? Do you have I'm guessing a lot of people would say, oh, that's so cool. Do you ever get the random, that doesn't work, that makes no sense? What is the general feeling of the people you interact with?
Yeah, definitely. And I think whoever asked this question probably also experienced themselves. As an innovator, you get misunderstood a lot. I mean, what is your reaction to my presentation today? I don't know what the sentiment is, but I think as someone who's really doing something new, you will find yourself in education no matter what. So that's why most research labs are in universities, is education. And you may want to make your products into an education product. Like this one is a little bit like that. It has an education element because students and open-minded younger people may accept it much more than the traditional thinking people. And you have to write education materials to teach people, like this is what it does. You're making something really new and not many people in the world understand it. So you have to create education materials to increase the adoption and understanding. So whenever you're doing something really innovative, you find yourself in the education space and you have to convince people. That is what it takes, is convincing your peers, convincing your upper management, convincing older generations. And that's why we need communication. That's why we have to tell stories and be good at education, in addition to being good at the technology itself.
Well, I think that's exactly what you're doing here today. You've shared this with us. You've told us your story. You've educated us in the process. And I think we're all very thankful for that. And we've learned a lot, and we can move forward with these new ideas that you have put in our heads. There are no more questions, it seems. So I'm going to thank you again for your time. You asked what the feedback was for your presentation. I know you will probably look into the chat later, but most people have said, bravo, well done, this is amazing. I want one of those t-shirts. Very nice presentation, very unique ideas. Dave told us, I love the team that EarthOS is quantum computing related. Perhaps Art is the Earth's quantum computing working with us to add value, something like that. I think that's a great thought to close with. So thank you, Dave, for that. And I would say again, once more, thank you. This was a really enriching experience for all of us. Again, the comments say everyone loved it. We are very appreciative of your time. And as I said before, this talk will be posted online. If you guys want to look at it again or share it, feel free to do so. And of course, check out the Live Innovation Live website. We'll have more events coming up for you in the future in 2021. Maybe some of them will even be live. That would be really cool. So now I'm going to stop recording and close this meeting. Thank you everyone for your participation.
Thank you very much for having me.
Thank you, Kitty.
Have a good day. Have a good Thanksgiving.
You too.
Bye.